In section F.4, we talk about the present value of annuities and amortizations. So let's start with an example. Let's say you work for the state, you run a lottery, and someone just won $500,000. The winner gets $50,000 at the end of each year for 10 years. We want to know how much money we need to set aside in an account that earns 8% interest to be able to make these payments. So let's think about this. So we'll break it down year by year. So for year 1, we need to pay out a certain amount, and then we need to put in a certain amount to the account in order to make that payout, right? So our payout has to be $50,000. But how much do we have to put in to do that? Well, that money will be sitting in this account that earns 8% interest for a year. So the amount I want to put in, right, times that 8% interest, right? So I have the amount that I have plus that 8% interest, 1.08. That has to equal that $50,000. So I can divide by that 1.08 and get the amount that I need to put in is 50,000 times 1 over 1.08. All right, so I just divided both sides here by 1.08. Dividing by 1.08 is the same as multiplying by 1 over 1.08. Okay, so let's do the same thing for year 2. In year 2, we again have to pay out $50,000. So I want to try to figure out how much I should put in. Whatever money I put in, let's call that P, that is going to be in that account for 2 years, so it earns interest twice. And after it earns interest twice, then it needs to be that $50,000. So I can divide both sides by 1.08 squared. But dividing by that 1.08 is the same as multiplying by 1 over 1.08. So I can think of this as 50,000 times 1 over 1.08 squared. That gives me the amount that I need to put in to make that payment after 2 years. And we can go ahead and keep doing this. I'm doing this all the way down for 10 years. So let's just think about the 10th year here. So again, for my 10th year, I want to pay out $50,000. So I need to put in a certain amount so that once that earns 8% interest 10 times, I get $50,000. So if I divide both sides by 1.08 to the 10th, I get that the amount I need to put in is 50,000 times 1 over 1.08 to the 10th. Okay, so let's focus on this amount that we need to put into the account here. Give ourselves a little bit more space. That amount that I need to put in is 50,000 times 1 over 1.08 plus 50,000 times 1 over 1.08 to the 9th. Sorry. Squared. Got ahead of myself there. Plus all the way down to 50,000 times 1 over 1.08 cubed. No, the last one, obviously, is not cubed. The last one here is the 10th power. Okay, so now what we're going to do is we're going to use our geometric sum formula to try to figure out what this is equal to. The problem is it's going to be a little weird because our first term, that should be our A, but it already has a 1.08 in there. So what I really need to do is I need to take one of these 1.08s away, 1 over 1.08. That gives me my A, and then I'm left with one more, 1 over 1.08. And then that is going to be my B. Right, so my first term is that 50,000 times 1 over 1.08. So that's my A. And then this term here, maybe we'll put that in green, that is my B. So now if we keep going down to this last term, I'll pull off one of those 1.1 over 1.08s. So I have my A. I've only used one of them, so what's left is 1 over 1.08 to the 9th power. So that's my B to the 9th power. So I have A plus A times B all the way down to plus A times B to the 9th power. So in my formula, this is going to be equal to A times B to the 1 more than we stopped with, so B to the 10th, minus 1 over B minus 1. So going ahead and plugging everything in, my A is that 50,000, 1 over 1.08, so that's my first term, times the B to the N, so then B is that 1 over 1.08, and I'm raising that to the 10th power here, minus 1 over 1 over 1.08 minus 1. In the next slide, we're going to do a bit more algebra to this expression, and then we'll come up with a general formula. But right, the way we have it now, we could go ahead and just enter that into our calculator and get an answer. Okay, so let's do a little bit more algebraic simplification on this expression. So the first thing I notice is I have two different fractions here. So I want to multiply those fractions together. So I'm going to first just rewrite the expression to really focus on my fractions. So the first one has 1 as a numerator and 1.08 as a denominator. And the second one has that 1 over 1.08 to the 10th power minus 1 as the numerator, and then 1 over 1.08 minus 1 as the denominator. So if we remember, when we multiply fractions, we just multiply the numerators together and the denominators together. So 1 times 1.08 to the 10th minus 1 is just 1 over 1.08 to the 10th minus 1. Right? And now I'm going to multiply 1.08. I'm going to distribute that to the two different terms in my denominator. So I have 1.08 times 1 over 1.08 is just 1.08 over 1.08 minus 1.08 times 1 is 1.08. Right, so I just distributed this term to both of those two terms. So that's going to be 50,000. My numerator is 1 over 1.08 to that 10th power minus 1 over 1.08 divided by 1.08, that's just 1. So I have 1 minus 1.08, so that's negative 0.08. And now we don't really like having this negative here, so I'm going to multiply top and bottom by negative 1. Right, negative 1 over negative 1 is just 1, so we're allowed to do that. When I multiply the top by negative 1, the first term, we'll keep the 50,000 out front. The first term becomes negative, so I have negative 1 over 1.08 to the 10th minus 1. Oh, that becomes plus 1 because I'm distributing that negative 1 to both of them. And I divide that by a positive 0.08. So finally, I like to have my positive number first and my negative number second, so I'm going to switch the order in that numerator. And we end up with this lovely formula here. Okay, so let's go ahead and see if we can take that formula and unpack all of the different pieces. So we'll have our PMT, so that's just the payment we need to make. Each, we'll say, time period, so it could be month or year or whatever. So the amount, the payment we actually have to make. So in our example, that was our 50,000. That was important for us. What other numbers came up? We had our N. That was our total number of payments. So in the example here, our N was 10, because we ended up having to make 10 payments total. And then we had our interest. So we'll have I. And we want this, like we did before, to be our interest per pay period. So we paid money every year. So we had our interest per year. So that was our 0.08. Right? If maybe you're paying every month instead of every year, then you would have to take that annual interest rate and divide it by the number of times compounded per year. So make sure you've got your interest per pay period, not your interest per year. And then how did we put all those together into the formula? Well, we ended up with our payment times 1 minus, here that 1.08 is that 1 plus I. So let's write that as we did here in the denominator. So we have 1 over 1 plus I. That's being raised to the n power. And then I'm dividing that by my I. And what that gives me is the present value of those payments. So how much money we need now to make those payments. So that's my PV, the present value. So that is the formula we need for questions like this. We'll do one more example on the next slide. Okay, so let's look at another example. We want to know how much money we need to put into account now that earns 5% interest compounded monthly in order to be able to pay out $2,000 a month for the next 20 years. So we've got our formulas laid out for us. So we have the present value, so the amount of money we need now, is equal to the payment, the amount we're putting out each time period. So in this case, our time period is a month, times 1 minus 1 over 1 plus I, where I is that interest rate per time period, to the n, number of time periods, over I. If you want, you could also rewrite this formula using negative exponents. So I can say here that 1 over 1 plus I, that's the same as 1 plus I to the negative 1. So I can write this as 1 plus I to the negative n instead. So maybe that'll make it a little bit easier to plug into something like Desmos. So you can see I've already pre-plugged this formula into Desmos, so I can just put in my p, I, and n value to calculate out that present value. Okay, so let's actually identify what our different pieces are. So the payment, that's just the amount of money you want to pay out per time period. So that's $2,000. And let's include here that that's per month. So now I know that everything has to be in months. So then my I needs to be the interest per month. So it's 5%, so 0.05 per year. I divide that by 12 because it's compounded monthly, and that gives me the amount per month. And then n, this needs to be the number of months, since everything is in months here. So I'm told that it's 20 years, so I take that 20 and multiply by 12 months in a year to get 240 months. Now we can go ahead and plug all these values in. So my P, move this guy over just a little bit so we can see all the numbers. That P is going to be 2,000. So plug that in. My I is going to be 0.05, oops, not 0.5, 0.05 divided by 12. And then my N is going to be 240. So we can find the amount of money we would need, and it just gives it in our formula here. So the value that gets output here is that amount. So the present value that we've calculated is $303,050.63. Right, so we got that by doing that 2,000 times 1 minus 1 over 1 plus the I value, 0.05 over 12, to the 240 divided by that 0.05 over 12. All right, so that's a lot of kind of stuff to put into this formula. It's a lot of stuff to put into the calculator. So I would definitely recommend using something like this formula in Desmos because it allows us to really see all of the different steps we're doing to make sure we're not making that calculator error. Let's look at one follow-up question here. So let's say we wanted to know the total number of interest that we actually paid. So let's give ourselves just a little bit more space. Ooh, that wasn't good. Okay, so let's just squeeze in here whatever our total interest is. Well, I know that I paid out $2,000 a month for 20 years. So I paid out $2,000 times 240 months. But the amount of money I had in the bank, that present value, was $303.50. So then my total interest would just be the difference between those two. So we can go ahead and calculate that out. So let's go ahead and have Desmos do that for us. So I'm just going to do that 2,000 times 240. So I ended up having, right, $480,000 that were paid out. The amount of money I had in was $303,050.63. So the amount of interest I had was $176,000. $176,649.37. So we can calculate those by sort of thinking about where this interest comes from, right? It's the amount of money that we were able to pay out that we didn't put in originally. So if you sort of think about what each of these values are, you can help answer questions like that. Let's look at an example with mortgage payments. So let's say you take out a $200,000 30-year mortgage with an interest rate of 3.92%, and we want to know that what our monthly payments are. So because we're thinking about monthly payments, we're going to think about this interest being compounded monthly. So it turns out we have the same sort of formula we have before, where we have the present value, and that's equal to the payments times 1 minus 1 over 1 plus I to the n, all over I. Here, I want to think of this present value as the amount of money I'm borrowing. So that's going to be that $200,000. And I know my interest rate, I, that's my 0.392. And because it's compounded monthly, I have to divide that by 12. And then I have my n value. So that's going to be 30 years. But it's compounded monthly, so I multiply that by 12. So I can plug in all those values, and what I'm trying to do is figure out my monthly payments. So I'm trying to solve for that payment. So let's go ahead and solve for that payment first in general, so that we have our formula here. And then we'll go ahead and plug in the values. So the payment is equal to, I just need to divide by that fraction. So that's the same as multiplying by the reciprocal. So I'll still have that present value on my other side. And then the denominator will become my numerator, and the numerator will become my denominator. So I'm dividing over that fraction. Okay, so this tells me the payment if I know the present value or the amount of the mortgage I'm taking out. So from here, I just need to plug in the different values. So my payment is equal to the present value, which is that $200,000, times my interest rate. We want the interest rate per time period. So that's going to be my 0.0392 divided by 12. So that's my I. And then that's divided by 1 minus 1 over 1 plus that I again, so 0.0392 over 12. Right, that's my interest rate. We have to do it monthly. To the n, where the n is that number of payments, 30 times 12. So then we can go ahead and put this into Desmos. It's going to be helpful probably to put it in as a formula like we did before. So we can put this in. And then we'll just put in our I value and we'll put in our n value and it calculates it out for us. So if I put that all in, I'm going to get payments of $945.63. Okay, so let's ask a follow-up question here. How much interest did we actually pay? To figure out how much interest we paid, we just want to look at the amount we paid and subtract the amount we borrowed. Right, so of that $200,000, I have to pay that back, and the rest of what I pay is just the interest. So the amount borrowed was that $200,000. The amount paid was my monthly payment times the number of times I paid it. And when I subtract those, right, subtract away that amount that I borrowed, the rest gives me my interest. So if I calculate that out, I get that I paid $140,426.80. Right, so I had a $200,000 mortgage. I paid that back, and in the process, I had to pay $140,000 worth of interest. All right, so let's say you've won the lottery, and you have two options. You can either get the lump sum payment, so you get $2 million right now, or you can choose to get $5,000 a month for the next 50 years, and you have to decide what you should choose. So obviously, there's a lot of options, things to consider. There's some tax implications. There's, how much money do you want right now? Maybe we don't want to have to wait. We want to have more money sooner, right? So this is lots of simple, more complicated things, but we're going to kind of do a simple calculation and assume that if we got those $2 million, I would just stick it in a bank account, and we're going to assume there's interest rates of 2%, and then just pull money from that every month so that I would be able to pull an equal amount for 50 years. You can kind of think of it as an amortization. Or maybe you could just get that $5,000 a month. So what we can do is we're going to calculate the present value of that $5,000 a month. So we'll calculate the present value. So how much is it worth now to get $5,000 a month for 50 years? And then I'll compare that with the $2 million, right, which has a present value of $2 million. So let's go ahead and write out our formula. So the present value is the payment amount times 1 plus 1 over 1, 1 minus 1 over 1 plus I to the n over I. So we can identify all of our variables. So the payment is $5,000, and that's a month. So I have to make sure everything is in terms of months. My interest rate is 2%. We always need it to be in the same units as our payments. So it was per month, so that needs to be per month. So we're going to assume it's compounded monthly here. And then the number of times I'm going to get a payment, I've got 50 years times 12 months a year. So that's going to be 600 payments. So I can put these all together into my formula to find the present value. So I have 5,000 times 1 minus 1 over 1 plus 0.02 over 12 to the 600 divided by 0.02 over 12. I've got my formula preloaded here into Desmos, so I can just put in those different values. I put in my 5,000 for my P, my 0.02 over 12 for my I, and my 12 times 50 for my N. And it tells me that that present value is $1.895 million. So $1,895,442.62. So that's less than that $2 million. So we should take the $2 million. Let's actually make that so you can read it. So let's go ahead and take the $2 million. Okay, so maybe a follow-up question. If we take that $2 million, how much can we, let's say, pay ourselves, right? So we're going to take that $2 million and we're going to stick it in the bank, and then we're just going to take money out every month for 50 years. So it, gets down to zero at the end of 50 years. So that's going to be the same as our amortization payment. So I'm going to have my other formula here. So the payment that we can make to ourselves is the present value, that $2 million, times I over 1 minus 1 over 1 plus I to the N. So our present value here, that's our 2 million. My I is that interest rate of 2% divided by 12. And then our N is going to be the 50 years times 12 months in a year. So again, we can put all of those pieces into Desmos for our other formula. So we've got 2 million for the present value. The I and the N stay the same as before. And we find that if we have that $2 million, we can take payments of $5,275.81 per month, right? So again, we can also see that that's higher than the 5,000. So there's two different approaches to this problem.